Hey guys, welcome back to a new video. In this video I will actually give you a full guide to testing a clean architecture app. In case you missed my recent clean architecture video, then you can see that here, in which we essentially made this node app. So if I quickly drag this over here, you can see we just have an app in which we can save nodes, we can edit these nodes here, we can give it a different color, save it again, and yeah, just add new nodes. We can order these nodes and all that cool stuff. So in case you missed that, you should really watch this video. In this video, I will actually give you an introduction, or rather a full guide, not an introduction. It will be a full guide on how you can test this application. So I will be going over unit testing, integration testing, and end-to-end testing. So those are the three major types of tests we can have for an app. And I will explain all of those here in detail. Why do we actually test our application? I'm hearing that from beginners over and over again, because writing test cases of course takes time. And especially if you are a beginner and you never wrote test cases, it quickly seems like it's a waste of time because they don't do much. But the reason for that is usually that you haven't worked on quite bigger projects yet, because then test cases pay off so much. You can't really not have test cases if you want to have a stable and solid app. So the whole purpose of test cases is that we can verify that our app works. But not only verify that our app works, the thing with test cases is that we can verify it over and over again with just a single click. So we just need to click run test cases and it will automatically run all of our test cases and tell us if our app works as expected. So the bigger your app gets, the more time you will actually save, because you don't need to manually test everything. Because the thing is, whenever you change something in your source code, it's not only this specific feature in which you change something that you need to test. You actually theoretically need to test everything, because you could have broken some other part of your app when you worked on some kind of feature, and test cases really help you to detect that so much easier, because it doesn't really cost you anything to run test cases except for some seconds. So that is why you should really learn writing test cases. That is a very, very important skill in the industry, and to get a job, your employer will like it if you know testing. So watch this video till the end. Let's talk a bit about the different types of test cases we actually have. On the one hand, there are unit tests. Unit tests are kind of the smallest tests and the fastest tests. These should make up the majority of your test cases in your app, so approximately 70% of your test cases should be unit tests. Unit tests, in the end, just test single components of your app, so that can be a single class and could also be a single function, usually just a single function in a single class. But they don't test how classes work together, they don't test any other larger behavior. No, a unit test could just be, here in our app, that the ordering actually works. So that if we call our use case with an order title descending, that this is actually ordering this list correctly. That would be a unit test. So it tests business logic. Then one layer on top of unit tests are so-called integration tests. Integration tests just test the behavior of two classes working together. So those could be any two classes. For example, here, if we test that, if we click on this toggle section, that it actually disappears, and if we click it again, that it appears. So that would be an integration test if we just test this behavior, that we can toggle this order section, because it tests how our actual UI, so the composable, interacts with our view model. Because the view model contains the state of the screen, and if we click on this order section button here, then the view model will actually toggle the state, give the result to our UI again, and the UI will then hide it accordingly. So in the end, just two components are working together here. And then there is one last thing, which are end-to-end tests. These should make up about 10% of your test cases, so integration tests 20% and unit tests 70%. End-to-end tests are really are quite big tests usually, and they really simulate user behavior here. So that could, for example, be what we will do here, that we click on this add button, that we enter some title, that we enter some content, that we change the color, that we then save the node, that we then assert, okay, is the node really in our list, that we then click on the node, that we edit it again a little bit, that we save it again, we verify that the editing worked. That would be an end-to-end test. So just a normal user behavior. Or it could be that we click, or that we add a node, then delete the node, click undo, and then just check if the node is in the list again. That would also be an end-to-end test. So those three types are actually the types that you will encounter over and over again when working with test cases. And these are the ones that I will show you today. So let's actually jump into coding here. In case you haven't watched the video, then you can get the source code here from the link in this video's description. Make sure you get the initial source code, because I will also publish a final source code where I will include the test cases here that I will show you in this video. So get the initial project from my GitHub repository, and I'm on the testing branch right now, on which I will write the test cases. First things first, I want to add some dependencies for our test cases. You can already see there is a test implementation here, Android test implementation. What's the difference? Test implementation is for local unit tests. So these unit tests run on the local JVM here, so they don't need your emulator to run. That's why they are also so quick, because they don't need an Android device to run. If you take a look here in your project, then you can see you have a test directory and an Android test directory. The test directory will contain your local unit tests. So those will only be unit tests that you will find in here. In a clean architecture project, that is the tests regarding your use cases and maybe some utility classes where you just test single components of your app. And then you have this Android test directory, which contains instrumented unit tests, so not integration tests, it's called instrumented unit tests. Those could also be unit tests, but they are related to Android. So they need Android components such as the context, such as UI tests, for example, that involve compose or fragments activities. So basically any Android components, and these don't run on the JVM, therefore, so not only on the JVM, but instead they need an emulator to actually run. And when you then take a look here, you will see that we have test implementation, Android test implementation. So if you use one of these, then the following dependency will only apply for the single source set. So for either test or Android test. So this dependency won't be included for our production build, because it wouldn't make much sense to include test dependencies for our production app. That's why we have Android test implementation and test implementation. And there's also debug implementation, which is also used for some dependencies. What I will do is I will actually remove the JUnit 1, and I'm not sure if I include the other ones in the dependencies I will paste now, but doesn't really matter. I will now paste testing dependencies here. And now go through these. So on the one hand, for our local unit tests, as I said, here are all these test implementations. This one should actually also be test implementation. So just some core dependencies. It might be that we don't need all of these here. Those are usually just the test dependencies I paste for all of my projects, because you need these quite often. So yeah, just some basic test classes that this will include. Then we have JUnit. JUnit is the testing framework for Java and Kotlin, which we use here. So JUnit is responsible for actually running your test cases and making sure, or just checking that there is an initial setup, and then you do something, and then it asserts that a specific condition is met. That is, in the end, a test case. That's the responsibility of JUnit. Then, that's also some more utility stuff. I don't even know what exactly is in there. We have coroutines, specific test dependencies. So in case you want to test coroutines, you need that. Truth is an assertion library by Google, which makes assertions much more beautiful than the default assertions by JUnit. Then we have a mock web server, which we don't need here because we only deal with a local database. But in case you need to test your API, then you can use this mock web server to simulate network responses, so you don't need to make the actual network calls. We have marking libraries, or rather just one marking library, which is mark_k. I won't get into marking here in this video because we don't need it. You can watch my testing playlist. I go into marking there, so you just check my playlists and you will find that. This will just make sure that our UI tests don't crash for a specific reason. I don't know what exactly that does, but I needed to include it. Otherwise it always crashed. Then instrumentation tests. So for the Android test source set, we use hild. So I will show you how you can use hild to write test cases and inject dependencies in test cases. JUnit as well, coroutines as well. Yeah, the rest is pretty much the same. So we can click sync now and hop into coding. So let's actually finally start to write our first test case, and that will be a unit test. So unit tests are just the easiest tests, and that is why I start with this. What do we actually unit test here in our app? Well, I already said in a clean architecture project we unit test our business logic. I mean, you always unit test your business logic, but here the business logic is located in the use cases. So those will actually be the classes that we unit test here. It could be that you have some just util classes that are not use cases. Yeah, those would also be classes you would unit test. So, which of our use cases in our feature node can we actually unit test? Let's take a look at add node. Yeah, we could do that. We could, for example, test that if the node title is blank, it really throws that exception. And if the content is blank, that it really throws that exception. And if both are not blank, we could test that it really inserts the node. But I will actually not do that. That will be your homework. I will take the getNodes use case, because that is a bit more complex. And here we just make sure that we will return the correct order if we pass the correct order. So, I mean, if we pass or node order date descending, that we actually order the list by date descending. That is what we want to test here, just for all different types of ordering. So we can go up here to getNodes on the class name, press Alt plus Enter, and then we can click Create Test. We will name this a getNodes test. So that's the convention, just the class name you test, followed by test. We don't want to use JUnit 3, we want to use JUnit 4. There's also 5, but I think that doesn't work for instrumented unit tests. You can make that work for local unit tests, but I will just use JUnit 4. We don't really get any big benefits here of using JUnit 5. So just use that, click OK, and now it asks us in which source set, in which folder we want to create that test. That is a local unit test. We don't need any Android components here for this use case, so we can put it in our test directory and click OK. And there we go. That's your first test case. Now the first thing when we run a test case is to ask ourselves, which dependencies do we actually need here? What do we need to actually create a getNodes use case? Well, we need a repository, so that is what we actually need to create here. And we of course need the use case itself. So let's start actually with that. So that will be a private latent var getNodes of type getNodes. And then we can create a function which is called setup, which we annotate with @before. So what this will do is, this will tell JUnit that this is our so-called before function. So it will run the setup function before every single test case, and well, it is used to set up things that we need for every test case, such as just initializing some objects, like our getNodes use case. So getNodes is equal to getNodes, just a new object, and now we need to pass a repository. Well, what kind of repository do we pass here? We could pass our node repository implementation, and yeah, now we need a database. How do we get the database? We don't have one, because we are of course here in our local unit test source set, in which we don't have access to Android components. A room database is an Android component, it needs the context to be created. So that doesn't work here. And even if it would work, we wouldn't do this, because you don't want to test with your actual database or your actual API. Test cases should be quick. and they shouldn't rely on any data writing logic and actually writing data persistently on your disk or uploading it to a real API, at least not unit tests. So we need to think of something different here. So what I like to do when dealing with repositories for testing is to create a so-called fake, so a fake repository. And I think I mentioned that when I actually implemented the app here, so in the actual video, that we often do that for test cases. So a fake repository is basically just something that simulates the actual behavior of our repository. And we can then use that for a test case, but under the hood, it really only uses a simple list. So we only save our whole database, well, which is not really big here, in a simple list. Because our use case, of course, doesn't really care where the data comes from. It only needs to know which data it gets. So what we will do is, we will go to our test source set, feature node, go to new package, data.repository, right click and create a new, how do we call this? Fake node repository. And now it comes in handy that our repository is actually an interface, because now we can make this fake repository inherit or implement our node repository interface. So we make sure that it has all these functions it needs. We can press Ctrl I, Ctrl A, enter. And now we can create our very own version of that repository that simulates our database. So, as I said, in the end that will just be a simple list. And I know if you never did testing, then this will look very weird here what we do, and it doesn't feel right, but it is actually right, trust me. So we can just have a private val nodes here, which is a mutable list of nodes. When we get our nodes, we just want to return a flow of a list of nodes. So we can just return a flow of our nodes. That is how we could simulate that. Actually, not of nodes, we want to emit nodes here. Then, to get a node by its ID, we can say we return nodes.find. We want to find the node that has the same ID as we pass here. That is how we could simulate that. To insert a node, we can say nodes.add, and we add our node to the list. And we can delete a node, so nodes.remove node. It's really as easy as that. And that will now simulate our actual database with just a simple list. And our use case will now make use of that repository, and it will just get the same data as with a real repository, just adjusted for a single test case. I mean, of course, not the same data as with the real repository, so we don't get anything from our database now, but it for the use case, there is really no difference where the data comes from. So now we can say in our test case, private latent var, fake repository of type fake node repository. We can then initialize that here, fake node repository, and that now does not take a parameter. And then we can simply paste it here. And that is now the reason why in our node use case, we made that an interface. Because now we're not forced to pass our actual implementation that uses the database here in our test case. Instead, we are free to actually create our very own fake version of that for our test cases, and we don't need to change anything in our use case for that. Now, is there actually more setup that we need here to test the ordering of our nodes? Yes, there is, because we of course need to have some nodes in our repository to be able to check if the ordering was correct. So what I will do is, before every single test case, so in this function, I will just pre-populate our fake database here with some nodes. So we can say val nodes to insert. It's just a mutable list of nodes of a node. And then how I will do this to check this is I will just have a range from A to Z. Then we can say for each indexed, so we have our index and our character. And we will just insert 26 nodes here for each single character. So nodes to insert dot add. We can create a node. Title will be the character.toString. I'm just doing this to have something we can actually check with if the order is correct. So we just insert nodes from A to Z, so we can check, okay, if node with title A is actually before node with title B, then we can say, okay, the order is correct. Content will also be c.toString. Then we have the timestamp, which will just be the index too long, and the color will be index. So it really doesn't matter that we enter some dumb values here. All we really want is to verify that the order is correct. Now if you insert these nodes here in the list like that, these of course are already ordered. That is not what we want, so it wouldn't be a surprise if this makes the test case pass. So what we want to do after we inserted these, we can say nodes to insert that shuffle. So we just shuffle our whole list to make sure we have a random order, and then we can simply say nodes to insert for each, and we just insert every single node into our repository. So fake repository, insert node, and we pass it. That is now a suspend function, so what we need to do is we need to execute that in run blocking. So just put that in here. And then we're actually good to go. Now we wrote the setup for our test cases, and the next step is to actually write the test cases. So let's do that down here. Whenever we have a test case, to just tell unit, hey, that's a test case, re-annotate this with that test. Then we have a function. So each test case is a function, and the cool thing for local unit tests is that we can use these backticks to name our functions, because we don't really call these functions on our own, so they don't need any really good names. Instead, they should just tell us what the function tests. And the name I give my test cases is always first, what do we do with this test case, and then what should it return? Because then it will, when we run our test cases, all the test cases will appear and it will say, okay, order list by title ascending, correct order. So what we actually expect to happen. And if it fails, there will be a cross and we will see, okay, the order seems to not be correct. So we can say order nodes by title ascending, let's start with that, correct order. And now, in here, we actually need to write the logic for the test case, which is very simple in this case. First, we actually need to call our use case with the order we want to check for. So val nodes is equal to get nodes, passing node order dot title, so we want to order by title, ascending, so we say title ascending, and because that returns a flow and not a list, we want to say that first. So we just listen to the first emission here of that use case, and because that's a coroutine, just a suspend function, I mean, we need to execute that in a coroutine, for which we can use run blocking in test cases. Now, so far so good. We have our list of nodes with the given order. So we said, okay, we want to order by title ascending, and now what we want to test is if the order is really by title and ascending. So now we need to write the logic for that. And for that I will just use a simple for loop. So we say for I in nodes.size to, actually in a 0, to nodes.size minus 2, because now we will take a look at two nodes that are next to each other and just check that the first node is actually less than the second node. So in this case, according to the title, so that the title string is alphabetically sorted correctly, you can say. So let's take a look how this works. We can just say assert that, and that is an assertion function. So here we now want to make sure something, and if this fails, our test case will fail. If it succeeds, our test case will succeed. And there is an assert that function in JUnit, which I don't want to use because we use our truth library that we imported. So we're going to remove the JUnit assert block and then re-import that from this truth library. Then, what do we want to assert? We want to assert that nodes I dot title is actually less than nodes I plus 1 dot title. So we now loop over our whole list and we make sure that it's in the correct order. That's all we do here. And if we now execute the test case by clicking on this icon here, click run get nodes test, then you will see it will instantiate that and actually run the test case. And if we did everything correctly, it will pass. And you can see it actually passes. There is a beautiful check mark. So let's imagine we actually now go to our use case and we accidentally change something, or in future we change this use case and we say here for the title ascending, sorted by descending. Now with our test case we just need to execute that again to detect that we actually made a mistake here, and that this is actually covered by our test case, that we see, hey, this doesn't work as expected. You can see now it fails. It expected to be less than y, but was z. So that's just what was in our list. But in the end, then we see, oh, something is wrong. We need to go to our use case and actually fix the bug here and change it back to sorted by. And just for completeness, let's finish this test case class and do this for the rest of our values we can order by. It's very easy, just copy and paste here. So we paste this, actually 3, 4, 5, 6 times in total. Then we want to order by title descending. So we change this to descending. Then we make sure that it's actually greater than if we are ordering descending. Then we want to order by date ascending. So we swap this out with date. We make sure that we have date here. Actually, timestamp it's called. Here, timestamp. Then we have date descending, date descending, timestamp, and timestamp. Then here we have color ascending, so color, color, and color. And we have color descending. Descending, color, and color. So that was really quick. Now we have test cases that fully cover our use case, or at least these sorting functions here. And if we want to run all of these test cases, we need to scroll up to our get nodes test and click here on this icon and click run get nodes test. And this will now run all of our test cases. You will see they will hopefully all pass. And no, they actually don't. Seems like I did a mistake. Let's click on that. Order nodes by date descending, correct order. Yeah, you see I did a mistake because I forgot to change this to is greater than. And here as well is greater than. But if we now rerun this, then every test should actually pass. And there you go. And this is really the best the best thing about test cases. If you see this, you almost get an orgasm. So that is already it for our unit test. As a homework, in regards to unit test, the video is not over yet. You can test this add node use case. So you want to write 3 test cases here. As I already said, you want to test, okay, if the title is blank, do we really get an exception here? If the content is blank, do we really get an exception? And if we have a valid title and valid content, do we really insert the node in our repository? So have fun trying that out at home and really do that. Otherwise, you really don't learn. The next type of tests we will deal with here are so-called integration tests, as I already explained. So in our case here, we will just test the interaction between our node screen and our view model. So we will just write one UI test here for the node screen. You will see what that will do. I think I already said that. It will test that if we click on the sort icon, that it actually toggles that section. So it will test on the one hand the UI, and on the other hand the interaction with the UI with the view model. it doesn't mean that all integration tests deal with UI and view models. It's a common example in Android, but it could also as well just be two other types of classes that somehow work together. For that, I actually want to go to Presentation, Notes, Notes Screen, scroll up to our function signature, and again press Alt plus Enter. We say Create Test to create a test case. I don't want to name this Note Screen KT test. I just want to call it Note Screen Test. We can say OK. This time it uses Android components such as Jetpack Compose. So we want to put that in Android test. So every time you deal with UI tests, then you definitely have an instrumented unit test or just an instrumented test that needs to be in the Android test directory. So we press OK. There we go. We have our empty test class. And let's see what we will do here. So for instrumented tests, so for all tests in the Android test directory, we will actually use hild to inject our dependencies, because these tests can often involve quite some dependencies that we kind of want to inject here. And it's important to say that we can inject our normal dependencies from our normal DI module, or all of our modules actually. So if we just set up Dagger hild for our test cases now and we inject stuff that we provide here, then that works. But usually we don't want that, because our normal modules involve our actual production dependencies, such as our database. We don't want to have the real database in our test cases. We don't want to have the real repository in our test cases. So what we will do is we will actually create a test module in which we kind of override these dependencies here to provide these specifically for our test cases. And that is what we will do. The first step to set up hild for test cases, that is always quite a bit of setup, is to annotate the test case with add hild Android test. Then the next step will be to create our test module. So we want to go down to Android test, create a package DI, and it's quite important that you use the same package structure for your test cases as you use for your actual production app, because that just helps you much more to find stuff in the test directory. We can then actually take our app module and simply copy it in here in our DI package, call it test app module, and then just adjust it at the places where we actually need to adjust it. So the first thing is, of course, we need to change our database here. Do we even need a database here in our integration and end-to-end tests? Well, we don't need that, but I kind of want a database here actually. And the cool thing about Room is that it offers a so-called in-memory database. So it's basically just a database that is, well, in memory. So we don't write data to persistent storage that it will also keep after relaunching the device. No, it's just like a list. So we can just treat it as a normal database, and it basically then just gets cleared after the test case is over. So that way we get the closest to our actual setup while still keeping the fastness. Can you say that? While keeping how fast our test cases run, because it's in memory. So what we want to do is, instead of database builder, I want to say in-memory builder, in-memory database builder. That doesn't need a name here, so we can remove that, and that's already it. So now for our test case, we provide that in-memory database, and that will also be provided for a repository. So here we will actually take the same repository as we use for our production app, because that just takes the node DAO, which we can get from our database here, and just our node use cases, which will also stay the same and just take this repository instance. So how does this work? Now we have our test app module, and the next step is to tell our test case we want to actually use that test app module and not our actual app module. So what we do is we say add uninstall modules. So we can say, hey, Dagger, please don't use these modules, and we just put in our app module. So by default, it would just look in all of our directories for modules, and it would use our test app module and our app module, but it would lead to some conflicts because we define some dependencies multiple times. So what we do is we say, okay, please don't use the app module, so it will only find the test app module and will use its dependencies here that we just provided for this test case and for our other test cases. Now, one more thing when we set up Hild for test cases is that we need to create a custom test runner class, because you might remember that when we set up Hild here, then we need to annotate our application with this Hild Android app. And in test cases, we don't use our Node app here as a root application class. Instead, there will be a custom one, I think from JUnit or so, and that won't have this annotation Hild Android app. So it won't really work. So we need to create a test runner for which we will define an actual application class that has that annotation. So what we will do is we will right click here on our Android test root directory, create a Hild test runner. That will be a class. We'll inherit from a JUnit runner. Is it Android JUnit? Android JUnit runner. This one. Then in here we can override a new application, and you can see we return super new application, and here we have a class name of the actual application that we use for this test runner. Instead of this class name, we want to say Hild test application class .java, and because it's the name, we want to say that name. So that is how we can define this custom test runner. We also need to register that in our build.gradle file that JUnit actually uses that. So we go to build.gradle app, scroll up to this test instrumentation runner here. You can see right now it's set to the default JUnit runner. So we want to go to Hild test runner, copy our package name, and simply paste it in here and say .Hild test runner, so, or whatever you called your class. Make sure it's exactly the same, because otherwise it won't work, it won't find it. We click synchronize now. We can close this, we can close this. And now we just made sure that we use this custom Hild test runner for all of our instrumented tests. So let's now actually start working on our actual test case on our UI test. So that was a lot of stuff that we need to set up once, but not for every test case. So what comes now is actually what you need to do for every test class, not for every test case. And of course this stuff as well. But this test runner is just once for your application. So what we will do is we first kind of need to make sure that we can inject dependencies here in this test case with Dagger Hill. Sadly, this annotation isn't enough. We also need to define a so-called rule. So in JUnit we have different types of rules that we can define that will just give us specific behavior for our test cases. So there could, for example, be an activity rule that helps us to do activity stuff, like sending intents, receiving intent results. And as well as that, there is also a Hild rule that gives us the behavior to actually inject dependencies. So we will say add get :rule, and then we say val Hild rule is equal to Hild Android rule. And here we need to provide the test instance, which is just this. So with this rule, we can actually then call an inject function in our before function, so before every test case, to just make sure that we properly inject the dependencies. That's not the only rule we need here, because we deal with compose. We want to have a screen, we want to simulate a UI test here basically, and for that we need the compose test rule, so that we can actually simulate clicks, that we can simulate swipes, that we can make assertions on views, that we can actually find views, or composables rather, on our screen. For that we need the compose test rule. So again, add get rule val compose rule, and that will be create Android compose rule. There's also the normal compose rule that will just give us the behavior that it will just launch a new component activity, so just a normal compose type activity, and we can put composables in that. However, we want the Android compose rule, because with that you can see we can specify our own activity that we want to launch. That's important because the activity should also have this annotation here, Android entry point if we want to inject dependencies in that, such as our view model. So we need the Android compose rule to make sure we actually launch our main activity and not any other random activity. And yeah, to actually make sure that this rule applies first, so before this one, because we first want to actually inject our dependencies, we need to define an order. So we can say order is 0 for this, and the order is 1 for this. So we say, okay, please apply this rule before this rule. And now we can take these two rules and do stuff with these in our test case. So the first thing I usually do is just use implementing the setup function for a test case. So add before, we already have that. Function setup. And what do we want to do here? So first of all, we want to inject the dependencies. We need to do that actively with our hilt rule by saying hilt rule dot inject. So that will just make sure that whatever we inject here in this test class, or whatever we inject in dependencies we use here, such as our composables, will just be injected. And the next step, what we also want to do in setup is we actually want to set up the screen. So we can now use our compose rule and say set content, and here we set our custom content for this specific test case that contains the stuff we actually want to test. And I always make my test cases as isolated as possible, so we don't want to use our actual app here that we set the content to. We could do that, but we really only want to involve the components that we actually test here in this test class. So in that case, that's only the node screen. We still want to wrap that around a nav host object actually, because that way hilt will automatically inject our view models, because these are bound to the navigation graph. So we want to get a nav controller instance first. Remember nav controller. Then we want to assign our theme, so clean architecture node app theme. And then we have the nav host, passing our nav controller, and we want to set a start destination. Let's do that in the next line. We use our screen class to get the route for that. That's the node screen dot route. And then we can define our actual composable here. So we will now only have one composable for the node screen, because that's what I mean with as isolated as possible. We don't include our added node screen here in this nav host. So the route will be again screen node screen route. And then in here we just put in our node screen, passing the nav controller. Then we need this annotation, experimental stuff annotation here. And that's actually the basic setup here for this UI test. So before every single test case runs, we just make sure that we inject the dependencies and that we set the content to this specific composable, so in the end to our node screen. And now in the actual test cases, we can make assertions and actually take actions on this node screen, so we can simulate clicks on a specific icon and then make sure, okay, is now this order section actually open or not? That's what we want to do. So down here, test function click toggle order section is visible. So that is what we want to test. Here for instrumented tests, we sadly cannot use this backtick way of writing these function names. So I usually just do it like that, with underscores to separate what we actually do and what we expect. There is no general right or wrong how you name your test cases. Different people will do it differently. I will teach you how I do it, how I like it, and that is exactly how I do it. And I will just do one UI test here for this node screen. Feel free to extend that, but you should just get how it works. And of course we will then work on the end-to-end tests, which will be more detailed and which will contain more assertions and stuff. So let's think about how a UI test actually works. Every single UI test first contains a part where it needs to find a specific UI component in our UI, so specific composable. It should actually either do an action on or do an assertion on. So we can either say, okay, find this button, click on it, or we can say find this text field, put some text in it, or if you want to do an assertion is we could say, okay, find this text field and make sure the text is actually Android. Find this button and make sure it is actually clickable. That would be an assertion. So we first need to find the composable we actually want to do something with. And that is, in this case, the order section. So when we freshly launch our node screen, we want to first make sure that the order section is not initially displaying. So how we can do that is we use our compose rule. We use that always here. Dot on node. And now you have, now you can see that we have a bunch of so-called matchers, I think it is. So we can now use one of these functions that will help us to match either just one composable or multiple ones. So we can say on all nodes, then we can pass such a matcher to just determine, hey, all nodes that maybe have this specific text or contain this text. Or we just have one node with either a content description, a tag, or a text. So if you have a text field that already contains a specific text, you can use this onNodeWithText function. If you have an image with a content description, you can use this function. But in our case, our actual order section doesn't really have a content description and doesn't really contain a text. What we actually need here is we need onNodeWithTag, and that allows us to pass a custom test tag to associate our composables with, just to make sure that we find a composable that has a specific tag, and that is only relevant for testing. So we can go to node screen, scroll down here to our order section, and for the modifier, we can set a so-called test tag, just to make sure that we find this order section in our test cases. So actually, when you have a content description or a text you can find your composable with, then it's better to use that, because these test tags just can make your production code a bit messy because they don't do anything for the production stuff. But if you don't have that, then this is the only real way. So we want to define a test tag here. For that, I like to create a constants class, maybe in a core package. So just core.util, let's call it like that. And in here we just have a constants class called test tags. Then we can say const val order section maybe, and then we can assign that here. So test tags order section. So far so good. And then we can put that in here. So test tags order section. And now we can assert something here. We can do something with that order section that we now either found or not. But we actually want to assert that it was not found. So we can say assert does not exist. So with that, we just make sure, try to find the order section, but please make sure that you actually don't find it. Well, the next step is to actually click on our toggle icon. So on our sort icon that will now make the order section visible. So we can say compose rule on node, and this time we actually have a content description. So on node with content description, and that is sort. Ideally, you should use string resources here, just to make sure that when you change this content description in your node screen, where is it here? For this icon we want to click on, that it also changes in your test cases. I think I said that in the video that I just keep it simple there. In a production level app, you would use string resources, and also if you want to access the application context in instrumented unit tests, then you can do that using application provider, get application context, and you just pass a context. So that is how you would get the context in a test case, and with that you could also get access to resources. Of course, only for the Android test directory. So now that we have this, that we found this icon we want to click on, we just want to say perform click. So then we simulate that click on that composable. And then we now want to assert that this order section is actually visible after clicking on this icon. So we can copy this line, and instead of asserting that it does not exist, we can assert is displayed. So that way we just make sure, okay, please check if it is displayed on our screen. And that's already our very first integration UI test. So let's run this. I'm not sure, maybe I missed something. We will see. I'll just run this here and let's check if it actually succeeds. So let's see. Test case is launching. It's installing the app. And you should now see how actually the compose testing library simulates all these actions. So now the test composable is launching. It clicks that, the order section was visible, and you can see our test succeeds. So that works fine. And if we would actually now change our production level code that it doesn't switch the order section, then of course the test case wouldn't work and it would actually catch that. So of course this looks like a lot of setup for a single test class. Yes, it is, but don't forget that usually you don't just have a single test. That is just for simplicity here. You could do more test cases here, take it as a homework. For example, what could you test? You could test that you can actually toggle this order section, that you can select every single radio button, that you can again close it. That's also something you would test. And there's actually not so much more, because the other stuff that we could test here with this list of nodes will be already tested in our end-to-end tests. So that is actually what comes next. But of course, if you have a screen with many potential UI operations, then there is a lot of stuff to test. So next step, end-to-end testing. So for that, I will actually create a class in our nodes package, or no, actually in our presentation package, because it involves multiple screens. So new Kotlin class of file, nodes end-to-end test, I will call it, and select class. So now the last big step here for test cases are so-called end-to-end tests. I already explained that a bit. These will test the actual user interaction. So these will try to simulate what a user would really do in your app, and not just toggling a section or so. Instead, that could really be, like in our case, what we will do is, hey, click on this floating action button, actually create a new node, click on save, make sure that the node is now in the list, click on the node, update the node, click on save again, and make sure that the update is also in the actual list. So quite big test cases here that can involve multiple screens. And the test case setup here will actually be exactly the same. So we first have HILT Android test. You can see now that will be a lot faster because we already did that once. We can go to our node screen test, copy our two rules, and we actually also need this uninstall annotation. So uninstall modules, app module, double colon class, and we have a before function, so setup, in which we say HILT rule .inject. And now for the actual content here, we will again set up a custom nav host, which will in the end just be what we have in main activity. So I will just copy this, but I still like to copy it and not make this a composable, because it's not usual that you only have two screens in your app. And if we only want a UI test that involves only these two screens, then I would still make that a custom nav host for your test case. So we can just copy that. We can say compose rule, set content. We make sure that we wrap that in our theme. And then we paste it in here. So quite some setup here for the composables. We get an error here for the annotation, but that should already be it. So we now make sure that we have a nav host that involves both of our screens here, so we can actually make sure that we navigate between these two screens. Then, as I said, the first end-to-end test we will write here will be that we save a new node and then edit it afterwards and just make sure that the editing also works, and of course the saving as well. So we can go down here and create that. That will be a little bit bigger test now. Function save new node, edit afterwards. That is how I will call this. And well, what is the first step we want to do? First, to actually add a new node, we need to click on the floating action button. So compose test rule, or just compose rule, on node with content description, which will be add here. That's the content description of the icon of the floating action button. And we want to perform a click here. So I want to click on that. Then I make a little space here because now we are on the next screen, just to distinguish that a bit. Now on the actual edit node screen, what do we want to do here? We want to actually enter some text in our title text field and in our content text field, and then click save. So how do we find our title and content text field? Well, for that we again kind of need test tags. I'm not too sure if we can use the hint for that, if that will allow it to enter text, because the hint is actually just a text composable and we can't enter text in a text composable. So I will just create some test tags here. If you want, feel free to try that out at home if that works. We will have the title text field, and we will have the content text field. Like that. And then we need to apply that in our code. So at edit node, that will be in our transparent hint text field, where we just need to be able to pass a test tag here. And to apply that, that actually needs to be on our basic text field, not on the outer box. So we cannot put this in this modifier we pass from the outside. Instead, it needs to be in this modifier. So dot test tag, we just specify the test tag. Then in our edit node screen, let's open that. Scroll down to where we create these transparent hint text fields. And here we can then easily just assign a test tag using test tags, title text field, and we have one for the content. Okay, back to our end-to-end test. We want to say compose rule on node with tag, test tags, title text field, and we want to say perform text input. So that will just add the text that we specify to this title text field. And I will rearrange that a bit. So for example, test title. Then we can make the same with the content. So we enter some content, call it test content. And now we're actually good to click save. You could also change the color here, but I won't do any assertions with that. So we can say compose rule on node with content description again, which will be save here. We perform a click on that, and that will now, if it works, it will navigate us away from this edit node screen and actually get us back to the node screen with our list, where it should display that new node. So again, I make a one-line space here to indicate we're now on another screen. So we now want to make sure that there is actually any type of node in our screen, in our screen that contains this text. So we can say compose rule on node with text test title assert is displayed. So that way we make sure, okay, the node is now actually in our list. The next step is that we use the compose rule and click on that node. So on node with text test title, perform click, because now we click on that node and we want to edit it now. Then we are on another screen again, so the edit node screen. We want to make sure that now the title and content text fields actually contains the title and content of that node. So compose rule on node with text, or actually not text, or not with tag. We use our test tags again, title text field, and here we want to make sure assert text equals. So we can say, okay, we make sure that the text in that title text field is test title. So what we actually used for the title for that node, test title. We do the same for the content text field. So we say content text field test content. And if that fits, we want to change one of these. So the test title, we want to add some text to that. So we can copy this. I want to say perform text input. So as I said, that will just edit. So for example, just a 2. So we have test title 2. Then we want to click save again. So compose rule. On node with content description, save, perform click. And now we just want to make sure, can we find a node in the list that that has the text test title 2. So compose rule, on node with text, test title 2, assert is displayed. And that's your very first end-to-end test here. You see that is quite a bit longer than what we did here for this integration test. So again, here we can actually write some comments, click on fab to save a new node, or rather to get to add node screen. Here we enter texts in title and content text fields. Here we can say we save the node, then make sure there is a node in the list with our title and content. Then what we do here is we actually also click on it here. So click on node to edit it. Make sure title and content text fields contain node title and content. Then we want to, oops, not here. Then we want to add the text 2 to the title text field. Save the node, or rather update the node. And finally, make sure the update was applied to the list. That's really what we do here. So also people who see this in GitHub can easily understand that. Let's actually run this test case. We haven't done that yet. And also open the emulator, because it's quite exciting to see that the first time. So let's see. Hopefully that works. You can see we actually have our screen. Oh, and it failed. Okay. Did we miss something? Failed to perform a gesture. Expected exactly one node, but could not find a node that satisfies content description add. So it seems like it can't find our floating action button. So let's quickly check that in our node screen. And oh, it's actually called add node, you see. So let's rename that to add and launch our test case again. And that should hopefully do it, if I didn't mess up any other content descriptions. And that, by the way, wouldn't have happened if you would have had string resources. So you see now, yeah, now we get to the add edit node screen, and it failed again. Let's see what it is now. Now it can't find a content description save. Did I call it now save node or what? Let's check our add edit node screen. Floating action button. I called it save node indeed. So let's launch it again. But I think we have no more content descriptions here, so it should be fine. And the app is launching. Add the node, update it, and now you can see now it actually worked. So yeah, test case passed. Congratulations. I will write one more end-to-end test here just to give you one more example, but I won't explain it in that much detail as that one because the video is already so long. So what I will actually do is I will add 3 nodes, then I will change the order, and we make sure that the order is also applied in the list. So test function save new nodes, order by title descending. Let's just test that. So we add new nodes, then we order by title descending, and we make sure that the order is actually correct. So first of all, I want to have a for loop here, I in 1 to 3. So we just add 3 nodes. Compose rule, we can actually copy the stuff from up here. This one until we save the node. Put that in here, just do that 3 times. Make sure that we just set the title here to either toString content as well. So we just have different titles for each node. Then here at this point we're sure that we have 3 nodes in our list. So we want to now toggle the order section. Or I would say we first actually assert that these 3 nodes are in our list. So on actually compose rule on node with text 1 assert is displayed. Duplicate that twice. Do that for our second and third node as well. And now, if that's the case, we can say, okay, we want to actually change the order. So compose rule on node with content description. Let's do it like that. This will be sort. So our order icon, perform click. And then we kind of need to find our radio buttons here, because we need to click in the actual button bubble and not on the text. So I will assign a content description for these as well. On node with content description, just title, so the name of the radio button, dot perform click. So make sure that we order by title. And then we make sure that we order by title descending. So we say descending. Of course, we didn't assign that in our source code, so let's do that in a node screen, actually not in a default radio button. And for the radio button, we can also assign a content description using a modifier. Modifier.semantics. And here we can say content description is just equal to, what is it? The text. So the text next to the radio button. So here I like this semantics and content description more because it actually also gives us the accessibility benefits of using content description instead of just using a test tag, which wouldn't give us these benefits. So here we now made sure that we have these content descriptions. We clicked on descending, so the order should now be applied, and we want to make sure that it is actually applied. So we want to say compose rule, this time on all nodes with tag, and here we need a new tag for a specific node item. Let's again create that in our test tags. Node item. And apply that here in our node item composable. Modifier test tag tags.nodeItem. So on all nodes with the tag node item, that will give us now a list of items it can find. So if there are multiple nodes, it will give us all these nodes. But we only want to get the first one, so we can index that at 0. And we can make sure that the text contains 3. Because the first node it should find, so at index 0, should actually have the text 3, because we ordered by title descending, so the 3 should be on top and the 1 should be at the bottom. So let's do that for the other 2 composables at index 1 and 2, and have 2 and 1 here as the text. So if we now launch this test case, check our emulator, and hopefully I didn't mess up any content descriptions again. So we add 3 nodes here, 1, 2, 3, title, descending, and yeah, it works. Test case passed. And if you want to run all your test cases, you can just go to Android test, so all instrumented tests in that case, right click, run tests in COM, so that will run all tests in the specific package. And yeah, then you will have different tests. Oh, we also have the example test here. So now it just runs all your test cases, and you can always do that with a single click to verify that your application works. And the best thing is really that you get all these check marks in the best case. If you want to run all your unit tests, you just do the same with the test directory. Here we don't need to take a look at the emulator because they don't run on the emulator. So these always take a bit to set up, but then these run super quickly. You can see 6 milliseconds, 4 milliseconds, 2, and so on. So that's the purpose of unit tests, to just run very quickly, and you have a lot of them. So that is it for this video. In case you actually like this testing stuff and clean architecture stuff, Android, Kotlin, and you want to learn more about that for free, then you will definitely like my email newsletter. So you will get my tips right into your inbox. So you want to check down the link to that newsletter where you can sign up for free. And yeah, then you will get all these Kotlin Android advice in your inbox. You will definitely benefit from that. And I wish you an excellent day. See you in the next video. Bye bye.